Today I'll be going over some of the questions that we looked at in the Phasor Edition Review number 2. First off, let's look at a couple questions in the first section. So question number 1. Question 1A. Question 1 asks us to find the horizontal and the vertical values, so the x and the y values for the following phasors. Question 1A gives us a phasor of 30 volts at an angle of 28 degrees. So, where do we start? First, we need to be able to plot these values on a triangle. Our phasor represents the hypotenuse of the triangle. And the angle at which that phasor occurs is represented here on our triangle. So I have a hypotenuse of 30 volts that occurs at an angle of 28 degrees. Before we go any further, we also need to label both sides of our triangle. This side of our triangle would be the opposite angle, side. And this would be the adjacent side. Now that we have our triangle appropriately labeled, let's write down our acronym for our trig functions. SOH, CAH, TOA. As long as we remember this acronym, we should be able to remember the trigonomic functions required to solve this triangle. First off, let's solve for the opposite. What trig function do I have that takes into account the opposite, the hypotenuse, and the angle? Let's use our sine function. What is our formula for sine? Sine theta is equal to the opposite divided by the hypotenuse. So what am I looking for here now, though? I'm looking for the opposite. So how do I isolate the opposite in this formula? Just some really quick cross multiplication. So I have the opposite is now equal to sine theta times by the hypotenuse. We all see how that happens? I place sine theta over 1. Then I can cross multiply. I can go 1 times the opposite is equal to the opposite, and sine theta times the hypotenuse is equal to the other side of the formula. So now the opposite would be equal to the sine of 28 degrees multiplied by our hypotenuse, which is 30 volts. So the opposite is equal to 14.08. Perfect. Now that we know the opposite, what's the next value we need to find? We need to find our adjacent. What trigonomic function can I use to find the adjacent? Well, I could use my tangent function, or I could use my cosine function. Cosine takes into account the hypotenuse, the angle, and the adjacent. So let's use cos. Cos theta is equal to the adjacent divided by the hypotenuse. What am I trying to isolate? I'm trying to isolate the adjacent. How do I do that? My handy dandy cross multiplication. So then I'm left with the adjacent being equal to the cosine of 28 degrees multiplied by the length of my hypotenuse, which is 30 volts. My adjacent is equal to 26.488. Fantastic. So what is the question asking for? It's asking for my x value. So my x would also be my adjacent, and my y would be my opposite. So my x value is 26 0.488. My y value is equal to 14.08. And that's how you solve question 1a. Now on to question 1b. Question 1b gives me a phasor of 80 volts at an angle of 90 degrees. Now this one's a little bit different. If something occurs at 90 degrees, is it not straight up and down? Absolutely it is. So in this instance, this phasor has no horizontal component. It is completely made up of our vertical component of our triangle. So we really don't even have a triangle. What we have is a straight line. So our x value would be equal to 0, and our y value would then be equal to 80 volts. Easy peasy. Now on to question 1c. Question 1c gives me 120 volts that occurs at 45 degrees. All right. Unfortunately now, we're back into drawing triangles. So let's plot our values on our triangles. My hypotenuse would be 120 volts, and the angle at which it occurs at would be 45 degrees. So, write out our trig functions again really quick, just so we remember. SOH, CAH, TOA. So what do we want to use? I want to start off with sine. So sine theta is equal to the opposite divided by the hypotenuse. This is my adjacent side. This is my opposite side. So I'm looking for the opposite. How do I isolate the opposite? Quick cross multiplication. Now the opposite is equal to the sine of 45 degrees times by 120. The opposite side would be equal to 84.9. Fantastic. Now let's solve for the adjacent. Once again, I could use the tan function or I could use the cosine function. Let's use the cosine function. Cos theta is equal to the adjacent divided by the hypotenuse. Cross multiply to isolate for the adjacent. The adjacent is equal to cosine of 45 degrees divided by 120. The adjacent is equal to 84.9. We can say that if our triangle has an angle of 45 degrees, that the adjacent and the opposite will be equal. So their x and y values will be the same. So the x value for this triangle is 84.9. The y value for this triangle is also 84.9. And that concludes the review for part 1 of the Phasor addition review. If you have questions on D, E, or F, come speak to me in class.